No, in general, there's two ways to look at how technology can improve lives. One way, if you look at large challenges like urbanization, longevity and so on, is really to go talk, work with the people, looking at challenges in the street. We're doing this in the smart city of things, city of Antwerp, where we're really co-designing with the people in the city to figure out what the problems are and then look for technologies that could solve those problems. That's one approach. The other approach is actually to grow basic technologies up to a level where they can be sufficiently mature that they can be deployed in the real world. And at imec we're actually tackling this from both sides. We have the smart electronics and applications that are actually looking at the real problems, the challenges out there. And we have the core technologies, process technologies, silicon technologies, which we try to grow up and mature to solve those problems. And when those two intersect, you have real disruptions, you can really improve people's lives.
Yeah, you're right. I think in general, technology means improvement. And we also see it from two sides. You have on one side the engineering side. Engineering tries to make things smaller. They try to make it faster, they try to make it better. You can see it on the chip size improvements, where you have much smaller chips with much more processing power. That's the one part which is generating or driving technology. The other part are people themselves, and people are lazy. People want to get things done in the most easy way. And technology can help them. And if you have those two sides together, so the more or less the laziness of people and technological improvement, those things together, they are creating innovation, and their technology really improves lives.
So the big mega trends that we have, urbanization, mobility and so on, I see those actually as there's three distinct groups. You have a first part that's really driven by societal problems, urbanization, mobility, dense city centers, and there we need technology not as a driver, it's an enabler. It actually helps solve problems created by those societal trends. That's one. The second one is actually the ones that are more driven by technology. I think about e-health, industrial IoT. We know what the solution looks like, we know we have the technology, but actually implementing it in the real world needs solutions in society. How do you cover e-health? How do you take care of medical data, patient data? What happens when everything is automated? What happens to the nature of work, of people on a factory floor? There it's really the society that has to provide the solution, and technology is the driver. And then the third block of big megatrends is what would be security, privacy, where both society and technology are creating problems right now that are moving faster than either one can solve. And I mean, privacy right now is a perfect example, but also cybersecurity, encryption, making sure that your data remains safe, self-driving cars, hacking self-driving cars, and there we need solutions on both sides.
I believe the megatrends themselves, they are not a phenomenon that we're seeing just as of today. So the megatrends themselves, they are existing since mankind. And for example, the phenomenon or the megatrend of mobility is, as of today, you see it only with different characters or characterisms than it was 30 years ago. 30 years ago, mobility as a megatrend has other characteristics than you see them today. Today we're talking about autonomous cars. 30 years ago we might have talked about everyone can own a car. Yeah, that's the kind of thing. I think I agree that things are belonging together. And it's they are also inspiring each other. So they are pushing limits. So the megatrend cannot really evolve or try to reach its vision without technology. On the other hand, technology is meaningless without the vision to reach something, to make some things better. And at the very end, if you look after our ecosystem, so technology, the megatrends, society, those challenges as a body, I believe that technology is really the nervous system of this. Technology is putting things together. It's able to transport information from A to B. It's the possibility to do it fast, to do it in a specific way for a specific use case. But all the other things, they really have to work closely together. And without these kind of connections and also direct relations, a megatrend is just a bunch of words, and also technology will never evolve without having a clear vision of what you try to achieve as a society or even from a technology perspective.
And then there's still also the intersection between megatrends, right? You have the e-health, you have mobility, but today even mobile e-health is becoming important as well. And the intersection between those two creates even more opportunities, but also challenges for technology.
And I think this is now coming onto this. What I said is the nervous system of this kind of future is that if you break it down to a certain extent, we are always talking about the same things. We are talking about how to connect things to each other, and how to transport the information to somewhere, and how to interpret the information to reach a certain goal or to reach a certain state you want to have. At the very end, these core components are always the same. It's transmitting data, it's getting a location, it's interpreting information from a sensor. The use cases are different. So you have a complete different use case in e-health, for example, rather than you have it for a smart city. But at the very end, the core components and the core technologies you're using are always the same.
Absolutely. I think we have actually, if you look at the network of the past or networks of today and the networks or connectivity of the future, I think we're actually at a very important change in the fundamental nature of the networks. Networks of the past are mostly about human communication, and they're often viewed from a human perspective. We build networks, why? Because we want to communicate. We build postal networks, we build telephone networks, we build mobile telephone networks to communicate. And then we did the same for entertainment. We first had traveling bards and circuses. Then we build theaters, but now all of our entertainment is part of the communications media. We can watch TV, play games at any time. It's all from a human-centric perspective. However, if you look at the future, more and more devices are coming on. You have machine learning, you have semi-autonomous artificial intelligence. I believe that those will drive the specifications, and the actual components stay the same, exactly as you said. The core is the same, but it will be driven by machine to machine is an old term, but let's say AI to AI interactions that we have, maybe will have completely different specifications, requirements, not coming from a human perspective. And I think that's an important thing to see when we look at networks of the future.
Absolutely. And even going further, and this is something what we are sometimes not really discussing as of today, is what happens if these autonomous or intelligent machines have to take decisions we have done before. And they are not doing these decisions in front of a human. So, okay, I want to watch this TV, or I'm using this gas station. But what happens if cars are really becoming autonomous and they have to decide which kind of gas station do I have to use for charging my battery? Which kind of garage I'm going into because I have to change my tires. Actually, these are things you decide as a human. There is human intelligence behind. In the future, there will be more and more things with more technological possibilities and more technological innovation, where these kind of decisions have been done by a machine, but also the counterpart will be a machine. So it's a complete different way of also interacting. I don't expect that machines, autonomous cars, will watch movies sooner or later, but they will take decisions we have done before, and these are the things what we discussed already previously, is that also these megatrends, their characteristics will now change by time. So in 5 years, the mobility or the urbanization megatrend we will see different shades of gray in there, and saying, okay, these are now new challenges because what we expected to become true then 5 years ago is then reality, and we are facing a new era of these megatrends.
Yeah, absolutely. And there is a shift here, right, in paradigm when we look at technologies and we look at AIs that are trying and making decisions, as you say, is that there is a concept of a Renaissance man, or there used to be the concept of a Renaissance man, right? Where this was a person living in the Renaissance, and at that time it was still possible for a single person to know all of scientific knowledge and understand it. And then I think we've shifted to the concept of the internet man. And the internet man doesn't know, but he can find all of the information and understand it. And I think we are now at a paradigm shift, and this is slow. You never see a paradigm shift, you see it in retrospect, right? I mean, it happened. I mean, industrialization, the internet, you see this in retrospect because the old paradigm continues to live on. Gibson said it, the future is already here, it's just not equally distributed, right? But the paradigm shift, I think, is that we are going towards a world where we cannot know, we cannot find the information. The best we can do, the man of the future, will know how to trust the decisions made by machines. How do you trust decisions made by non-human entities? And the understanding of trust is going to become more important than the understanding or finding of information. Which are the right decisions versus which is the right information?
Yeah, you're right. But at the very end, and then it breaks down, we are once again still talking about the same core underlying foundation, which already today is driving all these different ways of looking into a more connected future.
Yeah, I mean, the evolution of, well, even in general, evolution, I think, of organisms, the more complex an organism, the more communication systems it has, the better it can adapt itself to its environment. And that's why connectivity is so important to our world, why it is important, why we have edge IoT and edge AI, and we want to disperse sensors and compute capabilities and connectivity as widely as possible, because the better we know the world, the better we can understand, the better we can connect and communicate, the better we can adapt. And that's why it's so important that connectivity really becomes ubiquitous, and that everybody on the planet can be connected, because otherwise you will have pockets that cannot be lazy. Coming back to your original, it's essentially connectivity allows you, or makes it easier to be lazy, because you can get information without having to travel around. You know what other people are doing. You can make better decisions, or some machine learning or AI can make better decisions.
Connectivity today means you can access an ecosystem wherever you are. So you're coming to a building, you're coming into a certain area, and you have the possibility to access a certain ecosystem. That's how we see connectivity defined as of today. I believe that in the future this will also become a paradigm shift, because connectivity doesn't necessarily mean that you are connected to something, but you're part of the ecosystem, which is a fundamental difference as well. Actually, we are consuming as an end customer by far the most time, and now with the IoT coming in, which is also creating lots of innovation and driving lots of innovation because of this huge possibilities if you can connect everything to wirelessly to the cloud, to the internet, interacting things, this specific things already become part of the whole ecosystem, and this will also happen for everyone. So it's not sooner or later the Internet of Things, it's really the Internet of everything and everyone.
Frankly, I believe we can expect that trend, the Internet or connectivity using other or with other entities, will even continue. I mean, we have now the industrial internet. Quite often we think of factory floors, but you may know at Radboud University in Nijmegen, where we collaborate closely, there is a Twitter tree. And the tree is connected to Twitter, so when it wakes up in the morning, actually trees expand and they draw in water. It tweets, oh, I drank a nice amount of water this morning. This may seem silly, but if you think about the Internet of Plants, if you think about sustainable farming, and so on, everything which is agri-tech, that's going to be important as well. Can we build sensors that interface? Maybe we always think about brain-computer interfaces, which are very futuristic, but what about brain-plant interfaces? How to make trees happy, quote unquote, or plants happy, healthy? Maybe it's not the future of connectivity and sensing, because sensors are very important in that space as well. It's not about sensors that measure something, but sensors that just act as a translator, right? When I'm happy, I say I'm happy. You could put lots of sensors on my body and measure whether my skin resistance is X, my smile is Y, and so on. But for a plant, perhaps there is a way to also access directly the general well-being by accessing the neural system of the plant.
There is one part where bodies, brains become part of this ecosystem, become part of this connectivity. And it also, connectivity means sooner or later that this kind of what we call virtualization becomes more and more important. Also to run or to improve sustainability of existing systems. So for example, we have a project together in EMEA with some universities, some industrial players, where we're working on digital twins. And these kind of things also means that connectivity is lifted up to another level, because it's not simply a virtual system of the original system. It's really a one-to-one copy in time of this system. This means that if you're running something in your original plant or in your original system, it's exactly the same you're doing in the second system. However, you can still play in this virtual system in a way that you can try to figure out how would the real system behave if I'm doing some things. And this is, I think this is also some of these next level developments which will become more and more important inside of the connectivity part, maybe also in our personal lives, to get an idea about what happens if I do this, and you don't just try it out, you don't put your hand on the hot plate. Mm-hmm. It's more or less your digital twin who's doing this and giving you the results of this, and then you can still decide, do I want to apply or do I want to react in a different way?
So a digital twin of a human organ, for example.
For example, yeah.
So that's one of the things we're building, in fact, are electrode arrays with chips underneath it. So you can actually put a stem cell, a cell on top of it, and stimulate it to grow in different ways. And then you could indeed grow a virtual organ and predict what will happen, so you can try out cures and other items on that digital twin before you try it on your own body. Coming back to what you said, however, on the digital twin for factories and maybe predictive maintenance, when will something break down? I think that's one of the triggers also for those new specifications, new KPIs. I mean, if you want a network for those type of use cases, it's not about high capacity, it's not about gigabits and terabits, which remain important, it's also about reliability. If I have that digital twin, the network, and I have this close interconnection, the network needs to be up 99.999% for people to trust it, right? I mean, right now, if I would tell my family used to have a factory and said, well, we're going to connect all the machines to the internet, my father would likely say, you can't even hold up a call when I drive in my car. Why should I trust my machines on a wireless connection? I'm a techno-optimist. So I think technology will make the world a better place, even with the biggest paradigm shift that will be that computers make decisions instead of humans making decisions. I think that process will improve up to a place where indeed it will make our world in general, laziness or not, a much better place. I mean, Pedro Domingo said, we are worried that computers are becoming too smart and that they will take over the world. The problem is computers have already taken over the world and they're stupid. I mean, you've probably already gotten a letter. I mean, I get this from the local telecoms company. If I overpaid by 1 cent, the automated algorithms will send me a letter to say I have overpaid by 1 cent and they will refund it. The letter probably cost like €5. So computers are already making the decisions. I see, hopefully, optimistically, they will become smarter and the decisions will be smarter as well for the better of everyone.
So maybe I'm a little bit more realistic than optimistic. I think technology can help to make the world a better place. At the very end, and you mentioned it also before, is there are a few things and a few challenges already today which are not that nice. We have global warming, we have refugee crisis, we have political incidents, we have a kind of instability actually globally with these kind of things. We have extreme thoughts in different political different political parties, and I think this is something where also trends are part of, more or less. So we can't disconnect these kind of things. Where I'm positive, because the trends themselves always paint a bright future. When we're looking after the predictions for mobility, e-health, smart cities, it's always bright, it's always nice. I think what technology and the technology optimist sometimes underestimate is the human factor. And this is something we still have to deal with. I'm truly convinced that technology can really help in improving and in making our world a better place. We also have to ensure on the other side that the humans behind this, even machines become more smart and take decisions, at the very end it's still the humans that are driving the direction, and that we also have a common sense and a common direction we want to go for.
I agree 100%. I think that's in fact the biggest thing holding us back. That's the constraint on my optimism, is the fact that the human factor in accepting the technology is blocking us. And I think the most important key element in that is trust. I think we are slowly getting used to the idea of having machines making decisions. Even we accept them, even though we don't realize it, that they're already making decisions. But in many cases, and autonomous cars is a perfect example of this, people have unrealistic expectations or very high expectations of technology. The expectations we put, for example, on accidents by autonomous cars are much higher than the expectations we put on humans. I mean, we would never allow an autonomous car, an AI that drives as well as a grandmother, a general grandmother. You would never allow it on the street because it would be considered unsafe. And there's a point there, of course, that's because when there's an accident also in a factory and it's somehow a non-human entity making the decision, there's a big question: who is responsible? Who is the guilty party? Which is very deeply ingrained in the concept of a fair society. If something goes wrong, there is retribution, there is an action to be taken, and with the machine that becomes very hard. And I think that's the biggest thing holding us back, is to connect our human nature to decisions made by machines, and I don't think we've solved that yet.
We haven't, and this is also one of the paradigm shifts. If we looking a little bit back, we were always looking after reliability of systems. We had it sometimes in our discussion before. It's 99% on time. It's the possibility to have a call while the car is driving fast. This is about reliability. I think the big paradigm shift will really become that from reliability, we're moving to secure or trustworthy systems. So it's from reliability to secure and trust. And this is the biggest, I think, step to overcome. Once again, we need humans, because they are deciding, do I looking after reliability, or do I really trust something that is giving me an advice or driving me from A to B?
Just looking at the technologies very shortly, if I think about the connectivity of the future, and also we touched on a lot of that already, but the really big technologies, I think, fall into 3 or 4 categories. The first category is the one where you say, well, we know this broadband. We will continue to need ever more capacity, bigger broadband, and technologies like millimeter wave, better amplifiers, better networks, smaller, more power efficient chips, multi-modes connectivity and so on. That will be very important as we move along, and that's a big chunk of technologies that, frankly, the public or the biggest part of the people actually are knowledgeable about, or at least understand high capacity. But for the future networks, there's a second part of enabling technologies, which I would call maybe deterministic wireless networks, the reliable, on time, where we know when we send something, it will arrive. When we make a decision and we tell the machine on the other side of the planet to do A, or on the other side of the factory to do A, it will actually move and move in the right way. The protocol stacks, the software, the encryption on top of it so that nobody can break in and change your commands, perhaps even the machine learning to optimize those networks are critical technologies for the networks of the future. We have some of them already today in advanced Wi-Fi systems, but they will become even more important in the future. And then the third part, I would say, is the sensing technology, sensitive networks that work with very low power, that can live forever on a battery or no battery, that drives huge needs for integration, ever smaller systems, what we call BOM-less, so bill of material-less systems, so where you can actually integrate everything on the silicon and you don't need external components anymore, that perhaps harvest energy from RF waves, from the air, from movement, perhaps from the plant on which they live, they extract electricity from it. Those type of things is a third set of technologies. Again, if you look at Bluetooth, if you look at GPS receivers, the incredible improvement in power consumption over the last 10 years. I mean, you have 3 GPS receivers in a single watch, while you used to need a big box in your car. It has been incredible, and that needs to continue as well. So I think the enabling technologies for network of the future, we already know what they are, and that's probably the 3 big baskets. So capacity, determinism, and then very sensitive or very low power networks.
Yeah, and as we are really historically and already today being located and placed in one of these boxes, so looking after the connectivity, maybe a little bit with the sensor part, with our GPS receivers or GNSS receivers. I think also there is the border in between enabling technologies and implemented technologies. They are becoming blurry. It will be more and more towards highly integrated system, which is then more or less the enabling technology, which is setting once again the foundation. So I can totally rely on the information I'm receiving from this. And yes, it's about what will be, or how will the future will look like? So how will these networks as an ecosystem really look like? And you're totally right. The part how to transmit data, how to ensure that the data which is collected somewhere, maybe already processed somewhere, and transmitted to somewhere else to really build a logic, to build a use case, or to build even a business. We have to 100% ensure that this data cannot be manipulated. It's always your data. It's the data of the sender. This might be a human, or this might be even an IoT device, that this data which is created there and transmitted to another point, that it cannot be manipulated, that it's always clear that the sender is the owner of this data. And finally, even this will sooner or later become part of the enabling technologies. Coming back to the laziness of people, also engineers are lazy. Sooner or later, they don't want to think about anymore if this is something they have to design or not. It should be built in, which is what you said. Sooner or later, people expect, or engineers will expect, that all these functionalities will be already pre-built on a single mini chip, and they can simply use it straight away.
Actually, that's a perfect vision of the future, you could say. And you mentioned ecosystems also. I think the ecosystem is a key term there. Because of that much further integration, enabling technologies, the blurry line, ecosystems are becoming more and more important. And frankly, in the future, it may be even likely that the competitive entity will no longer be the company or the factory, but the competitive entities may be ecosystems. I mean, we have seen a little bit of connectivity of that in the past, right? You have the IEEE unlicensed Wi-Fi ecosystem, and you have the 3GPP licensed cellular ecosystem, which to a large degree are now accessing the same space. But in the future, you see companies like Amazon creating ecosystems around themselves on the logistics side, on the distribution side, on the manufacturing supply chain side. Companies like SoftBank that invest in Uber and in Lyft, and in Get, and in the third one, and they add content and they cross-fertilize over that ecosystem. The same thing for connectivity is also going to be key. And I think, frankly, the important thing of an ecosystem is a shared vision of the future. Ubiquitous sensing and connectivity built on a reliable trust base, for example. So from that sense, I mean, and that's also why we're collaborating. I think imec and u-blox belong to the same ecosystem, because we build the forward-looking IP, ideas, new potential concepts that may not work in the market, while you need and also develops to some degree those to actually build those components, subsystems that engineers expect, that they don't need to think about that underlying reliable layer anymore.
Yeah, and it also comes to the case that, especially in technology and these future, a connected future more or less, that it's turning from a supplier inside of this ecosystem to just deliver a certain service or a certain thing into this ecosystem at a specific time. It means also for you, as being a player inside of this field, that you have to be part of the ecosystem over the whole lifetime. You can't escape anymore. It's not like, you sell an ice cream and after the ice cream is eaten up, you're done and you have to buy a new one. It's really from cradle to grave, where you have to follow through delivering your expertise into the ecosystem, and also your expertise, which is on another level, to those things or people that are using the ecosystem.
Yeah, and the good thing about the ecosystem is, as it creates this web of interconnection, it also allows you to go for not supplier, vendor, traditional business models, but business models that look more at monetization as a service, which are necessary, because in that ubiquitous connected future, I mean, if you look at the technology that's really necessary, think about, I don't know, a high-speed ADC millimeter wave. I mean, the number of players that can own the entire stack, there's nobody left. Perhaps Intel or IBM, and even there. So you need all of those ecosystem players, and you need to connect the end user and how the end user takes care of this all the way back to that fundamental technology, because otherwise there will be no way to pay for the continuing advance.
So you mentioned before one name, which was Amazon, and I think we can't, within this part, we can't get off the huge tech giants actually today. So we have Apple, we have Google, we have Amazon, we have Facebook that are creating sooner or later their own ecosystems. And this is, we simply can't ignore. Google, for example, already, I think now 10 years ago, buying Nest, where everyone said, what the hell is a search machine? Looking with someone who's creating tiny little things for home automation. And today things are falling more and more together, but it's still the case that inside of these ecosystems, even those tech giants, they can't drive it totally by themselves. They need strong collaboration, they need carriers, they need the infrastructure to drive this, and they can't do it by themselves, because this would really dystopia. This wouldn't be a nice looking future. And I think it wouldn't be expected. And we're coming back to the trust and trust and security case if everything is owned just by the master of this ecosystem. So this is one part we surely can't ignore with regards to ecosystem. The second thing is, and this is also looking a little bit from a further level, is you need political stability, because these systems in a good world can only be driven and will be only secure and also trustworthy for those ones which are part of this ecosystem if you have a stable political situation where you apply these ecosystems.
Oh, absolutely. I mean, I think the underlying, and you already mentioned, is when you talked about the trust and the data ownership, a lot of those ecosystems are not necessarily technology or market ecosystems, they become data ecosystems where everyone wants their own data, and that data ecosystem, that's exactly where the touch point is with the political stable situation. Because access to certain types of data in a politically unstable situation, I mean, an accident waiting to happen, so agree 100%.
So I think the first obstacle that is really holding back more connectivity is money. So we have to be aware today where everyone's talking 5G. I've been on several exhibitions over the year. You have the feeling there is nothing else than 5G, and everybody's talking about 5G. There are you have lots of demos you see right now, how the future will be like with 5G, what kind of things in our life will really improve by applying to this technology. Reality as of today is it's slower than expected, and it's mainly related to the huge investments that have to be made. So money is really one thing that is hindering or holding back a total connected future. 5G is only one example. It would be for all the other things related to connectivity as well, that you need to invest quite a huge amount of money to come to this ideal state. And then it's, once again, we are not living in a charity community as of today. It's coming back how to get back the money for my investment. So we need to have a positive ROI to a certain extent. And the second thing, already mentioned a little bit, you need to also to have stable political systems. And it's sometimes you have societies, you have the technology, you have the brain inside of areas where technological improvement would be possible, and it's simply held back by the unstable situation around. And this unstable situation doesn't necessarily mean only that companies are not willing to invest. It's also that people or even governments themselves don't even know, okay, when I'm doing this decision, am I happy with this decision still tomorrow or 2 days after? This is something where I actually see this kind of obstacles for getting more connectivity, more technology, even on a global basis.
No, I think inside 5G even there's an example of this, right? When 5G was being defined in ITU, there were discussions in ITU. If you recall, there were a number of use cases defined: mobile broadband or enhanced mobile broadband. There was the ultra-reliable low latency. There was a massive machine-type communication. But people forget there were a number of other ones as well. One of them was, for example, ubiquitous connectivity, but at a much lower bit rate. So not 1 or 2 gigabits per second, but 50 megabits per second over hundreds of square kilometers, which would be ideal if you think about developing countries, Africa and so on, rural communities, to bring them up to the level to also have connectivity and the ability to have all of those automations, improvement in efficiency. But as you said, the investment environment just isn't there today, because a lot of the connectivity is being driven today by entertainment and communications. So it's mostly broadband, and the other use cases get some attention, but not sufficient. Absolutely, couldn't agree more.
And we also have to be aware that even as of today, as innovation cycles are getting shorter and shorter, so the next innovation level might be there in 2 years, where we say, okay, we haven't done the next technology step to the next level.
6G, 7G, 8G.
Exactly. At the very end is we have to be aware that the things where we are now talking about, so you mentioned before industrial use cases, automotive use cases, that the life cycle of these things is much, much longer than the next innovation cycle. So already today we have built things to last. We have built things to last much longer than the next technology step, the next technology evolution or revolution step. But at the very end, already today it's expected that the next few steps, the components and the core foundation we're building as of today is still up to date in 6 or 7 years. And also this is something where it's getting difficult for everyone to decide, okay, what should I do right now? 5G, once again, a perfect example. There they call it massive machine type communication. In the 4G area, they call it LPWA, yeah, which is more or less, it will be an evolution coming from A to B, but we already see as of today, there is the clear need and the clear requirement from markets, from ecosystems to say, okay, if we decide to do LPWA today, I want to do massive machine type communication in 5 years, but I don't want to change everything. And that's also, so it's an investment today, and if you don't invest today, you're just postponing the investment and you have to put the money on the table in 5 to 6 years when really everything is available.
All of that connectivity and talking about Africa and ubiquitous connectivity, I mean, should connectivity or technology be a human right? You've probably seen those pyramids, Maslow's pyramid of needs, where the bottom layer is replaced by Wi-Fi. I mean, and we spoke about this earlier, right? Where the communications and the ability to communicate drives evolution. So I think to that degree, technology and connectivity technology is a need, which means it should be a right, just like if you really need it to evolve, like food, like clean air, like water, it probably also should be a right. Now, there is an inequality, but at the same time, and this is probably my optimistic hat again, if you look at the world today, there are more people connected than ever. Healthcare across the world on average is better than ever. Access to education on the whole is better than ever. So while there is this digital divide and it exists, let's not try and look at it from there is a digital divide, because on the whole, things are getting better. We just have to keep an eye on it. And I think, frankly, perhaps it's not even technology that's a human right. It's education and understanding of technology. Because if we go to a world where connectivity means more and more decisions are being made by autonomous other entities, if people don't understand technology, and it's maybe also one of the things holding us back, if people don't trust technologies, then they will not implement it and they will react to it and turn away from the technology, like the Luddites in the 17 or 1800s. So I would say the basic human right maybe is not technology, but technology education, so that people understand technology.
Yeah, with regards to this, I also think is we need to first of all we need to find a good definition of the term technology in this case. Yeah, so what does it really mean? Is it the pure technology, so this nervous system which is just enabling things, or is it do we already mean to get access to certain information, to get access to certain ecosystems? So depending on this, I would say yes. If technology is defined as I have the right to access information, I have the right to access the ecosystems, I need to improve my life, to improve my situation, I would say yes, technology is a human right. At the very end, as we've spoken before, how we are now talking about technology is more like the underlying technology is more like the vehicle. For sure you need to have the ability to have access to these technologies to reach all the other challenge, or to address all the other challenges. And this is where it's getting a little bit difficult to really find a right answer on saying is technology a human right or not. What I agree to is this Maslow's pyramid, where I believe previously it was safety, it was food, it was housing, these core things you really need to reach the next level. As of today, things have changed there. It's these three other core foundations, they are still there, but access to information and the right also to spell out your own thoughts, to be able to articulate your thoughts, to participate at discussions. I think already this is something which has been added on this core. It's not only, not just about surviving, it's also becoming a vital part of a society that has, even in difficult times, has changed. And to this, and I mentioned it several times, is it's these, we need to assure also as societies here in the Western world that fundamental rights can be applied in different societies. And I think technology is a very, very good vehicle to help to do so, and also to sometimes raise the flag and say, hey guys, we should better steer into another direction rather than go in straight ahead to what you're doing right next to the wall.
Yeah, and I think that's also part of the role of our ecosystem, is to help people, to educate people, help people understand what technology can and what it cannot do, so that people know which technologies can tackle which of those challenges you just described.